This is part 12 in a series of videos in which I'm trying to develop a replacement for this. This is, if you haven't seen the previous videos, a tape drive from a Fluke 9010A microsystem troubleshooter. It uses tapes similar to this. This is not a Fluke tape. I've modified this particular drive to use cheaper tape, but even so the tapes are still quite expensive. They're a bit cumbersome to use, slow. It can take 10 or 15 minutes to write a single tape, and they're also unreliable and prone to damage, and if you've spent several hours entering data into the Fluke, it's very irritating, and it does tend to kind of put you off using the Fluke if you want to use it for detailed and complex scripting. So what I decided to do was to try and develop a solid state drop-in replacement for this drive. Obviously the interface to the Fluke is bespoke. It's obviously not a generic interface, and so what I ended up doing was starting from scratch, reverse engineering the firmware in the Fluke, and then I designed this, which is the prototype replacement for the cassette drive. It writes all the data to a serial EEPROM, and so all the circuitry is really geared towards taking the interface from the Fluke and making the Fluke think it's talking to a cassette drive. The only difference is it's much faster. It's 100 times or more faster than the cassette drive. And also, of course, there's the ability to switch banks within the memory, so one memory chip can replace multiple tapes. And then I thought I'd take it one step further and started looking into developing small memory cards as well. This is just a mock-up, it's not one of the actual cards, but this is the size and shape they will be, and that will have the same serial EEPROM that is used on the main board, and again each one can hold up to 8 tapes worth of data. So I'd gone through this design. I've made a few videos showing how I went about doing that, reverse engineering the firmware, and ended up with this working prototype. So the next step was to turn this into a board design, so I've done that. I ordered some bare boards and the prototype has finally arrived. So what I need to do now is take this board, get it assembled, and see if we can make it work and reproduce the functionality of the breadboard version. So what I'll do is I'll take this over to the workbench and get the parts fitted, and I'll come back and we'll see if it actually will behave as it's intended to. So that didn't take too long. This is the prototype board built up. The ribbon cable is a bit too long, but I want to be able to attach this to the logic analyzer, so normally probably something 2/3 this length would be fine, but I wanted to keep it in a fairly similar size and shape to the original cassette drive. It is just, obviously, as you can see, a much neater unit. Some of the parts are fitted on the back. These are the parts that are accessible through the flap on the front of the Fluke, and that's the flap through which you insert the memory cards. But this main board does have built-in RAM, so what we'll do is we'll get hold of the Fluke and we'll plug this in and see if it actually works. Okay, so we have the Fluke on the bench. I've plugged the memory unit into it, and the first thing we need to do is see if the Fluke will power up. As you probably saw in the previous videos, the Fluke is quite sensitive to its data bus, so if there's anything wrong with this, then it will prevent the Fluke from booting up and passing its self-test. So we'll power up the Fluke, and it's passed its self-test, which is a good sign. Excuse the flicker on the Fluke display, that's unavoidable, it's due to the camera shutter speed. And if this is powered up, we should have the green LED illuminated, which we do. So the next thing is to see if we can read and write data. Now, to save a bit of time, what I've done is I've taken the memory chip out of the development units. I've just unplugged the IC from the breadboard and plugged it into here, and it should contain some programs. So I should be able to just hit read and we should see the LEDs respond, and we should read the programs directly into the Fluke memory. So we'll read the tape, hit yes. That's a good sign so far, and it says it's finished reading. So let's see if there are indeed any programs. And there are, so that's looking extremely promising. There should be a few programs in here. These are just some nonsense programs I was using to test the breadboard unit, and as you can see, it's retained the programs in the memory chip. So what we can do now is we'll create a new program. I'll just put a couple of steps in the program. Okay, we'll exit the program, just check that it was created, and it's 20 bytes long. And what we'll do now is we'll try writing the memory into the memory board. So it's a multi-step process, so we'll see the red LED come on to indicate that it's writing, and then the yellow LED in the center will come on to indicate that it's reading back the data, and that's a validation step. It's making sure the data it's written to memory actually matches what's in the Fluke. So we'll try writing. And that seems to have succeeded. So I'll power the Fluke off, we'll power it back on, read the tape or read the memory, and see if the new program we created is still there. So power the Fluke off, give it a few seconds, power it back up. This green LED, by the way, it's not on the power rail of this board, it's actually actively controlled by the processor. So what I'll do, I'll turn the lab lights off, or at least one of them, so we can see the LEDs a bit more clearly, and it also stops the display flickering on the Fluke, as you can see. And so what we should see is the yellow LED come on when we read the memory. So it just takes a few seconds, and we should now have program 9 still, which we do, 20 bytes long. And of course all the other programs should also still be there. So we'll try creating one more program. Program 66. We'll put a step in there. Check that it exists. And it does. And we'll try writing that to the memory. And that seems to have succeeded. So once more we'll cycle the power. We'll read the memory. And we'll see if we still have the two new programs. So there's the first one. And there's the second one. And of course we still have the original programs as well. So I'll just turn the lights back on. So as you can see, it's far more convenient to use than the tape drive, and I've got a few more steps in development for this yet. I need to make sure it can reliably switch between the different banks. I need to make sure that it can identify the correct bank so it doesn't accidentally corrupt the data, and that's really a usability thing. It's not for data security, it's just to make sure that if you accidentally select a memory bank that's got something in it, then it will let you know. The other things I've made use of are the error message system within the Fluke. So we can detect various errors on the card. So I've just induced what should be identified as an error by the Fluke if we try and do something, and as you can see it's saying no cassette. If I put the switch back to where it was and try and read again, then it's working fine. We can select different banks on the dip switches. There's 8 banks on the main board, and then each of the memory cards that we can plug in also has up to 8 banks, and again they're selected with the dip switches, and dip switch 3 selects between internal and external memory. So for example, you could read the data from a card into the Fluke memory and then switch to internal RAM and then write that back to the memory on the card. And it's a very easy way of preparing your Fluke for multiple sessions by having the data available within just a couple of seconds of booting up the machine. Assembly is relatively straightforward. I haven't decided exactly yet how I'm going to go about providing these, whether I just provide them as bare boards or assembled units. But I'll post a few update videos, but if you've got any preferences, then please leave a comment. If you've got any comments on any other aspects of this, then please let me know. But hopefully these should be available within the next few weeks.